Probably the most important and most math-intensive procedure that you're going to need to master from Chapter 7 is the calculation of what are referred to as confidence intervals. Now, we've already used that term confidence intervals before when we introduced when we discussed initially the T-table. On page 388, we've even, you can see right there, confidence intervals. And I think I'm going to use this segment in order to discuss a little bit about what confidence intervals are and why they are important. Confidence intervals are used in order to help us determine the interval or the range within which we can expect a true population mean to lie. That's essentially what confidence intervals are. Confidence intervals are two numbers, a lower number and a higher number. So they represent an interval or a range. They represent an interval or a range. And it is within that interval or within that range that we can be somewhat confident or sure that the true population mean will fall. Now, why is that important, and what significance does that have? What importance does that have to inferential statistics? Well, it has a lot of importance to inferential statistics because how often are we working with populations? Not very often, right? We don't work with populations very often at all. What do we most often work with? Not populations, but samples. Well, guess what? Samples have uncertainty. Samples have error. Now, if you've been a regular watcher of my YouTube clips for this course, you know that error isn't something good or something bad. It's just simply that we have to keep in mind and know how to adjust for. Error is simply the information that we're not able to measure in a population. We can measure a sample. We can gather a sample. We can get a group of people together and ask them a bunch of questions. We can send all members of the Republican Party a survey and gather information from them. That's a sample. It's not the whole Republican Party membership. It's a sample of it. Likewise with the Democratic Party and a sample of Democratic voters, for example. Right? It's simply when we have a sample, that's what we are measuring directly. However, we know that our samples contain error. In other words, there is distance between what we can measure with the sample and what is reality out in the population, right? So I want to just pause for a second and bring you back to the table, the T-table. So if you don't have the T-table in front of you, go ahead and pause this video and get it, or turn to page 388 in your book. And this all relates. This is one of those tying it all together moments. If you look at this T-table, do you remember what I referred to these numbers that are in the middle and the rectangle in the middle? Those numbers are units of standard error, but more specifically, it's the amount of standard error that we could expect to occur by chance given certain conditions, given sample size or degrees of freedom and the task at hand, confidence intervals. Check this out. Guess what? Start to pick any column you want. In fact, let's just start with 90%. So don't pick any column you want. Pick 90% because that's the one I'm referring to. If you go to the column marked 90% confidence intervals and you look at the t-value at the very top, what's the first t-value you encounter? 6.314, right? What's the next one? 2.920. What's the next one? 2.353. What's the next one? 2.132, 2.015, 1.943, and on and on and on. Do you know what's happening to those t-values? What's happening to them? Are they getting larger or they're getting smaller? They're getting smaller. Pick any other column. Pick 98%. What's the first 98%? What's the first t-value you come to? 31.821. What's the next one? 6.965. Next one, 4.451, 3.747, 3.365, 3.143, 2.998, and on and on and on and on, down to 2.326 at the bottom. 99.9. What's the first t-value? 636.619. On down to what's happening. Pick any column at all, and what happens as you go from the top of the column, what happens to the t-value. So as you go from the top of the column down to the bottom of the column, the t-values get smaller. What does that tell you? That tells you that as sample size increases, the amount of error, or to be perfectly accurate, standard error, the amount of standard error, the amount of error decreases. As sample size increases, standard error decreases. One more time. As sample size increases, standard error decreases, because it only makes sense. As sample size increases, that means we're studying more of the population. That means there's going to be less error. Think about that. As sample size increases, that means we're studying more of the population, which means there's less error, there's less unstudied population. That's what we mean when we talk about sampling error. So, how does that relate to confidence intervals? Well, here's the deal. Guess what? Imagine, if you will, you have a group of scores, and you've worked with lots of groups of scores so far, and you calculate that group of scores, your sample's mean. You calculated a mean. Is that mean equal to mu? Is that mean equal to mu? No, it is not. It is not. Why is the mean not equal to mu? Why? Error. Because this mean came from a sample, and that sample contained error. But we want our mean to be a good estimate of mu. Remember estimate? We want our mean to be a good estimate, a good approximation, a good estimate of mu. So, what we can do in order to help determine how good of an estimate our statistics are is to build confidence intervals. And once again, something I started this it feels like an hour, started this segment with is to simply discuss what confidence intervals are. Confidence intervals are two numbers, or an interval, a lower number, and actually we're going to refer to that or call it the lower limit, and an upper limit, a lower limit and an upper limit, with the mean right in the middle. And it is within that interval that we can be confident that the true population mean lies. How confident? Well, that depends on how wide the confidence intervals are that we build. According to the table, we can build 80% confidence intervals, we can build 90%, 95%, 98%, 99%, or 99.9%. That's what confidence intervals are. It is an interval within which we can be confident, within which we can be to some degree confident that the true population mean lies. So in the next segment, we're going to delve a little bit further into this concept of confidence intervals.